As an introduction to structural analysis, we must first explain some principles of statics. We will discuss stability. What is stability? How can we discover if a system is unstable? And what are the differences between a stable and unstable system? Next, we will explain what are supports and why are they important, what are the different types of supports, and why do reactions develop in supports. Finally, we will explain what is equilibrium and how can we find equilibrium equations. Stability. So what is a stable system? When a stable body is pushed by a force, it will move proportional to the strength of the force. A small force will cause a small movement. A stable body returns to its original position when the force is removed. An unstable body will experience a large movement in response to a very small force. The body will not return to its original position when the force is removed. What is a support? Why is it important? When a support is added to a point, it restricts the movement of that point in one or more directions. When a beam is left in the air, it falls freely under its weight. It's unstable. When a support is added at the left end, it will prevent the movement of that end. But the beam will continue to rotate, and the right end will continue to fall until an additional support is added to the right end. At this point in time, the beam will become stable. Supports are needed to maintain stability. Support reactions. What is a reaction? When a car is pushed on a smooth level ground, it will roll freely with no resistance. To stop the car, you need to push back with an equal and opposite force. The force used to stop the car is called a reaction, because the amount of effort you need to exert to stop the car doesn't depend on your decision. It only depends on the magnitude of the original force pushing the car. For any support, when movement is allowed in a certain direction, no reaction develops in that direction. A reaction will develop in any direction when motion is restricted in that direction. Support types. In 2D statics, a point can experience 3 movement types, or 3 degrees of freedom. 2 translations in 2 perpendicular directions, and 1 rotation. A point with 3 motions allowed is a free point with no support. A roller support restricts only 1 translation at a point. The point is allowed to move in the perpendicular direction and is allowed to rotate. Therefore, the roller support has 1 reaction force. A hinged support restricts 2 perpendicular translations, but the point is allowed to rotate. The hinged support has 2 reactions. A fixed support restricts 3 motion types. The fixed support has 3 reactions, 2 reaction forces, and 1 reaction moment. A fixed roller restricts the point from rotation and translation in 1 direction, but the point is allowed to move in the perpendicular direction. Therefore, the fixed roller has 1 reaction force and 1 reaction moment. What is equilibrium? Equilibrium is a state related to the forces and reactions acting on the body. It means the net sum of forces and reactions acting on the body is zero, and therefore the body is stationary. Stability, on the other hand, is a property that depends on the geometry and kinematics of the body. If the body has enough supports to generate the needed reactions to resist any kind of force configuration, equilibrium can be attained and the body becomes stable. So, can an unstable body be in equilibrium? The answer to this question is yes. An unstable body can reach equilibrium for certain force configurations, only for certain force configurations, but cannot reach equilibrium for all the possible force configurations. What are the equilibrium equations? To reach a state of equilibrium, three equations of equilibrium have to be fulfilled. First, the force in the horizontal or x direction must be resisted by the reaction in the x direction. Sigma x equals 0. Second, the force in the vertical or y direction must be resisted by reactions in the y direction. Sigma y equals 0. Finally, the moment about any point caused by the forces must be resisted by the moment about the same exact point caused by the reactions. Sigma m equals 0.